Hello, everyone. Welcome to another Make a Code Monday video. My name is Max from the Innisfil Idea Lab and Library, and I have what I think is a pretty exciting project to share with us today. We're going to use the microbit to make a kind of treasure hunting game, a game where you are this character moving back and forth, this little LED sprite, and as you make your way through the grid, you have to find either the treasure for a smiley face, or if you are unsuccessful in guessing which one of the lights is the treasure, that means you've accidentally fallen into the trap, and you get game over. Game over. And so this is the simplest version of the game you can see here, where your character moves around, and then you have to guess correctly and hopefully find the treasure. But of course, we can try to spice it up a bit as we go. And so let's get started. It all starts at the website makecode.microbit.org. On that website, you can, for example, browse some tutorials or start a new project. That's what we'll be doing, of course, our treasure hunting game. And click Create. So, like all good games, we have an on-start block and a forever block ready to go. And the on-start block is a great place to make our player. To make a player in the MakeCode microbit editor, we're going to use some game functions, but we have to put our game sprite into a variable. So we're going to eventually create a sprite, but to do that, we need to put our sprite in a variable. And so under the variables drawer, we're going to make a variable, and we're going to call our variable player, because this is the thing that exists in the game that will represent our player, who can control this object's movement. So we press OK. We have a set player to 0 block, good enough for our purposes, with one small addition. In the game drawer, we're going to create sprite at 2, 2. So this one block already kind of has some brand new and interesting stuff. Well, first off, what's a sprite? Typically, when you're making video games and things like that, a sprite is any graphical representation on the screen that is not the background. So if you're playing, a game with more graphics than our microbit, the sprite would be your player, all of the enemies would be sprites. Anything that is controllable, movable on the screen counts as a sprite. So just think of the sprite as our character. So we're setting our player to a character that we can move, or that we will eventually move. And then we have this fun stuff, x2, y2. Well, it just so happens that the microbit has a 5 by 5 LED grid. The grid can be addressed by individual locations. The top left corner is 0, 0. The far bottom right corner is 4, 4. And the middle is 2, 2. And so all of these positions on the screen can be directly addressed by their coordinates. Luckily, there's only 25 total positions you can be on the screen, because it's only a 5 by 5 LED screen. So creating your sprite at 2, 2 is in the center. For our treasure hunting game, let's put our sprite way at the top left corner where it's safe to start, because the trap, could be anywhere in the bottom of the screen, but we'll set our player to the top where it's safe. In order to create our treasure and trap sprites, we start in basically the same way. Under our variables drawer, we're going to make a variable. The variables here are useful because we are going to manipulate our characters in all sorts of different ways, and the variable will keep track of their position, whether or not they are whether or not they're the treasure, whether or not they're the trap. We can check against all these things either by comparing their identity or by comparing their location, among other things. And so we're going to create another sprite. The reason why we're going through the trouble of making the sprites is because the game drawer includes all sorts of different functions and blocks that we can take advantage of when it comes to sprite movement, but in particular, as I was mentioning, sprite positioning and collisions. And so we can check to see if one sprite is touching another, because the sprite as an object has these different attributes that we can check and control, such as its position, but also if it blinks, the light's brightness. And so using the game blocks maybe adds some complexity because they're, kind of weird blocks, but they give us a lot of power over the content and function of our game. And so we have our treasure, create sprite at 2, 2. That puts that right in the middle. But of course, if this is a game of chance where we could either touch the treasure or touch a trap, we need to add something that makes its position random. Lucky for us, there just so happens to be, under the math category, some pick random bubble blocks. And so, yes, returns a pseudo-random number between the min and the max, inclusive of those two numbers. And so I can take that bubble and put that in its x location, and then take that very same bubble and put that in its y location. And so, of course, the microbit screen only goes from 0 to 4. So the first thing we got to do is change that to probably just only go to the highest number. And then in terms of its minimum possible, well, the top row is 0. I don't really want the treasure or the trap to end up in this top row, because I want to give the player some ability to move left and right before running into one or the other. So we're actually going to make both of these minimums start at, or I should say 1y, but x can still be 0 because x is left to right. So 0 for x would be here, but 0 for y would be the top row here. And so we can reset that a couple times and see that it goes to all sorts of random locations, but never goes into the top row, which is great. Okay, so that's our treasure. We still, I should say also our player still doesn't move or anything like that, but we have our player, we have our treasure. And again, the variable is great for us here because we as the player will never know what this number is until we run into it. But the variable holds in this random location sprite for us, which is great. So we need one more variable. You might have guessed it, I've said it a bunch of times. We need a trap. And so we say okay there again. Set trap to 0, except we're just going to duplicate this. The same conditions that make it possible for our treasure to be in a random location are also going to be true for our trap. So now, one of these dots is a treasure, one of these dots is a trap. Hard to say which one. And so now we're going to add some functionality for our player to move around. The input category has what we need. We want to use the buttons to move our character around. So on button A pressed is a good start. And then if you click the drop down, you can change that to A, B, or A plus B. I'm going to do B first for reasons that'll be clear in a moment. And so again, the game category has all sorts of fun stuff related to movement. All sprites have a direction, so that's what these kind of turn rights and move bys are about. I want to be a little more specific. I want to just change its X or Y directly. So the sprite change X by 1 is a great place to start. And of course, our player is named player. So we click this bubble and select our player variable. And so if the top left corner is 0, 0, and the bottom right corner is 4, 4, the coordinate, that means that numbers get larger as you go to the right, and they get larger as you go down. So our player changing its X position by 1 means that the B button will move our character to the right until they hit a wall. And of course, there's no way to go backwards yet. So we can, be a little lazy. We can just right-click this block and duplicate it. Slide that over there. And then the A button pressed is, of course, the button on the other side of the microbit. And we can change X by -1 to move in the opposing direction. So that's pretty good. We got a little kind of like surfing microbit character. To move our character downward, well, let's just duplicate this block one more time and place it somewhere like this. Change that to A plus B. And then, X has been very kind to us, moving left and right. But now we want to move down on our Y axis. And numbers get bigger as we go down, which means this has to be 1. Okay, so our character moves right, our character moves left, and they go down, deeper, deeper, deeper. They can't go up, which I kind of like for this game, because kind of like once you've chosen to go down, that's it. You've made your choice. You're deeper, deeper, deeper into this, I don't know, treasure cave. And so we made it to the bottom, but unfortunately, nothing happened when we touched that other sprite because we haven't worked out how the collisions will work in our game. And so that's, of course, the next step. So the first one, or I guess both of them are pretty easy. We have our forever block here, and we just need to check some conditions, check to see if some things are true. That means we need our friend, the logic drawer, and ask a little question. If true, then. So if whatever happens to be in here is true, then we do what's in the gap. So this block needs some sort of condition that is evaluated, and then it'll do whatever's inside if that condition is true. So our condition is luckily kind of very predefined. We know what we want to check for. We want to check if our player is touching the treasure. And under the game drawer, there is a is sprite touching block, which is quite nice. And so we can pop that in there. Of course, once again, we're dealing with our player. And this is where things get a little interesting. In a block-based code editor, usually like shapes connect with like shapes. There's a little diamond in here, I guess because you can put some things from the logic drawer in there, or not even. Very curious, because what we want is a bubble type shape. We want to go into our variables and pull up the treasure. And so even though the treasure bubbles round and that's a diamond, it's okay. Just pop that in right there. So if our player is touching the treasure, then, well, that's an easy one. Let's show a quick little smiley face just to let our player know that they made the right choice. And so let's check that out. Let's see if we can hit our treasure. So that was the treasure. If you notice, the smiley face showed twice because as long as we're in that coordinate, we're still actually touching the treasure. And so the first thing to do is under the game drawer, pull up this delete sprite button, because once we collect our treasure, the treasure is gone. It's not there anymore. So we want to delete it. And then check that out. So great, smiley face. And then now the treasure is gone. So this must mean that this is the trap. Nothing happens there because once again, we need to do a little trickery here. If you're feeling lazy, you can just right click and duplicate this other if block. And then say if the player is touching the trap. Well, we don't want a smiley face. Let's do a little frown face just for now. And then under the game category, we'll just call game over. And so game over. So if you hit that trap, it's all over for you. I'm so sorry. It's not going to be good. And so our player is here. They move left and right. They move down. They make a choice. Is this the treasure? Is it a trap? Oh, it was a trap. And then, you can reset the game manually. Is it a treasure to the left? Or is it a treasure to the right? To the right. Yes. Awesome. So I got the treasure. That was great. But of course, the game doesn't do anything now that you got your treasure. So we can add at least one level of more complexity in order to make the game, a little more engaging, perhaps. So we have a good foundation. We have a lot of good stuff going on, but we're going to sort of use a function in order to add kind of the next level onto our game. So I'm going to make some room here, and we are going to create a function for the very first time. So under the functions drawer, we have a make a function button, very similar to the variables drawer, but make a function is very interesting. And so we get to, of course, name the function. I'm going to call this start level. And so I should say the reason why we're doing this, what we're going to do is we can put new code inside the function, and then later on, when we want to start a new level in our game, instead of copy and pasting all the old code, maybe into the forever block over and over again for each level or something weird like that, we can just put all the code we need to start a new level into the function. And then every time we want to start a new level, all we have to do is call the function or ask the function to run. And so it saves us a lot of, fiddling around and things like that, which is very handy for us. And so I've called my function something, and I can press done. So now we have a new bubble here where we get to make our very own function. What we need to really kind of understand about a game, though, is how it works. When you're playing your game, when you touch the treasure's deleted, but the trap is still there. So that means what we need to do is create a new treasure for a new level. But since the trap is already still there, because the game is automatically over when they touch the trap, that means we don't want to create a new trap. We just need to move the existing trap to a new location. So that will be the work of our function, as well as probably resetting the position of our player, because at the beginning of our game, the player goes to 0, 0. And so we are going to change the position of our player, change the position of the trap, and then just create a new treasure. And so let's get working on that. Starting from the top down, we'll work on our player. And so our player in the game has many tools to set its location. So under the game drawer, sprite set x to 0. Once again, this is our player. Set x to 0. And then we're going to duplicate that because we want to set the player's y to 0, put him back in that top left corner. Moving on, we have our treasure. We want to create a brand new treasure because, again, the only way that the level will change will be when the treasure is itself deleted. So here we go. That means then with this whole set treasure to create sprite, we can just right click and duplicate this. That's going to happen at the beginning of each level. So put that down there. Our trap needs to be moved. We don't want to create a new trap, just needs to be moved. So that means, it's similar to these two blocks here. I'm going to duplicate this first one here, pop that anywhere in there, change this to trap, and then, we don't want to set the trap to a known location. That'd be bad. So we're going to right click and duplicate one of our random bubbles here, because X left and right, anywhere across the screen. And then, duplicate this one again. So this is a lot of duplication, even just like this. Imagine if we had to do this for each new level. Ideally, we're going to only do all this duplication once inside of our start level function. So the trap, needs a Y location. We already decided earlier that was going to be from 1 to 4. Of course, you can change different numbers, maybe to have a different feel for your game. So this is everything that has to happen at the start of a level. Reset our player's location, create a new treasure, and reset our trap location. We can already change the way some of the code works because we have the trap being created here, which makes sense, and we have the treasure being created here and the player, but really we don't need the treasure to be here because what we're going to do is, even for this first level, to really just make use of our function, under these functions, we're going to call start level because even level 1 is still a level. And so we're going to create and move all these things all at once. And so since the start level function has a set treasure, we don't need this set treasure here. So I can delete that block. There is some duplication because we're creating the sprite at a random location and the player, and then we're doing that again at start level, but for what we're doing now, that's fine. The start level will be called right after our player and trap are created. It'll move the player to its new starting position, create the treasure, and then move the trap again to a random spot. On start, maybe that doesn't make the most amount of sense, but it definitely comes in handy over here because as soon as we delete that treasure, well, we can add some fun stuff. Let's go under basic, and we're just going to add a short pause because just to give us a second to wait before we show our change score by 1 animation. So this block will give us 1 point on the board, and it shows a kind of a nice little starburst animation. And then after that, all we got to do is use our functions to call our start level. And so instead of copying and pasting all this code there, every time we want to start a new level, we can just call start level. And then that code will run. It'll put our player back in its home, make a new treasure, reset the position of the trap, which is pretty good. And so I'm going to zoom out one tick here just so we can see all our code at once. And it's quite a lovely little masterpiece, if I do say so myself. And we can play it. And so here's our character moving around. This one is the trap. So pressing A and B will reset. This one is the treasure. Great. And so we got the smiley face and the score bloop animation, which means here we are on a new level. This one is the treasure. Great. So another level. Here we go. Here we go. Ooh. Oh. Sad face. And then the game over animation. The fun part about using the score block is that after this game over text scrolls, it shows us our score. So my score was 2. Pretty good. So I can reset the game again and keep on playing, but I think we get the idea. And so that's all I wanted to share with you today. A game where we get to use the coordinate system within Make Code for Microbit and use that to create this treasure hunting game where we even went through the trouble of making a function. So I hope you enjoyed what we've done today, and I hope to see you on the next one. Thanks so much. See you next time.